Hello, and welcome back to the Ninox Learning Channel. My name is Andy. I'm a Ninox programmer and trainer. And in this class, we're going to talk about how we can utilize date fields and the content in those date fields in our calculations and formulas, and how we can use date content to calculate and compute some very important pieces of information like age and duration. We're also going to talk about a variety of date functions within the Ninox language. Let's go ahead and get started. Now for this lesson, we're going to be using a database called Calendar Tools. This database is stored as a template in the Nioxus member portal at www.nioxus.com. If you go to the website, nioxus.com, you can go ahead and log into the portal. It's completely free. You can download the Calendar Tools database, and everything I'm showing you here in this class today, you'll have it on your computer. It's unlocked, it's not password protected, and you can experiment with it and play around with it and use it to learn at your own pace or to follow along with our teaching here today. When talking about date content or date fields, the conversation quickly turns to date math, calculating information based on date data. Let me show you an example. We're going to go into our date math table, and we're going to bring up a record, and we have two dates. Let's say we have the dates May 1st through June 30th of 2019. Now there's a couple of things that we may want to calculate. There's a couple of pieces of information that we may want to derive based on these two dates and the range of time that they represent, both at the beginning and at the end. For example, let's go in and add a formula. We may want to know how old something is if it was born on May 1st. Now for this example, I'm going to change this to May 1st, 2004. I want to go back a couple of years. So we might want to know how old is something. What is the age of something that was born on May 1st, 2004? We're going to add a formula field, and here we can use the age function, AGE in all lowercase, open paren, the date we are aging, and close paren. And this will show us that, and we can go ahead and call this field age, something that was born on May 1st, 2004 is today 15 years old. The important thing to understand about the age function is that it measures age in years and years only. Now, if you would like to measure age in years and months, we here at Nioxus built a special function that you can use, and it works exactly the same way. Let's create a second formula, and this function call is age, capital Y, capital M, age, years, months. Again, open parenthesis, the date we're aging, and close parenthesis. This will return age in years and months. This will return a more precise measure of age in that it's not only 15 years, but 15 years and 4 months. Again, this function, the ageYM function, is a global function, and we talked about global functions in a previous video. That global function can be copied and pasted in the options section, global script definitions. It's a simple block of code. You can copy that from the Nioxus member portal, or you can download this database and copy it from the options screen. But again, the age, capital Y, capital M, the ageYM function, allows us to have a slightly more precise calculation of age. Now, age is fine in some situations. How old is this car? How old is this person? But there are other situations where we need to measure a duration. And we need to measure it quite precisely, specifically in days. Let's go back and change this date to what we had before, May 1st, and I'll change it back to 2019. Now, as you can see, the standard age function, the Ninox age function, is only telling us it's 0 years old because the Ninox age function rounds to the full year, and the duration of time from May 1st through today is less than a year. It's in fact 4 months. All right? And that's fine. But what if we want to measure the number of days over a period of time? Not just the amount of time that has passed from a single date up to today, but the number of days that exist on the calendar between two dates, a beginning and an end date. And the syntax for this function is days, open parenthesis, the first date, comma, the second date, close parenthesis. It will still give us the answer 60. In this case, it will be 60, and if we want to define the units of measure, we can do that in the number format, and all I did there was go into administrative mode, select the parameters for this formula field. We'll name this formula days duration, and I clicked on number format, and I'm going to add the unit of measure in the suffix section, and that will be space DAYS. Select it, OK it, and there we go. Now we have the numeric value 60 and the number of days. This is not the number of days aging from May 1st. That's 4 months. This is the number of days within a closed period of time, a period of time that has a defined begin date and a defined static end date. So we have the age function, which will tell us how old something is based on a single date up to today in years. Age ym, and that's lowercase age, capital Ym, this will give us a function that allows us to calculate a duration or an age in years and months. So if we were to go back to maybe May 25th, 1874, we know that that was 52,996 days between that begin date and the end date. It is in years, 145 years, and specifically in years and months, 145 years, 4 months. So this is the age ym, and the days calculations. Very simple, very basic, and easy functions for you to use to turn age data into calendar or chronological information. Let's look at a couple of other important and equally easy to use date functions in the Ninox language. I'll return to administrative mode. I'm going to create a new formula, and the formula is simply going to be the formula today. TODAY, all lowercase, open close parentheses. This function requires no parameters, and it will tell us exactly that. The date as it is defined on the computer that we're operating on right now. And on this computer, at this moment, it is September 4th, 2019. So the today function is crucial for understanding how long something has existed or how it is aged or a duration. This duration, this 52,000 days, that's a little bit much. Why don't we maybe change that to 1975 instead? 16,000 days, that was 44 years and 4 months. This day's duration, remember, requires two dates, the beginning date and the ending date. This ending date is not going to change. If we want, so that's what we call a static calculation. The two parameters, beginning date, ending date, are not going to change. Therefore, the answer is not going to change. It's always going to be 16,107 days. If we want to do a dynamic calculation based on today, we can edit the formula this way. The beginning date, and instead of a fixed ending date, the parameter today. As The date of today advances one day at a time via the passage of time. The number of days in this range will continuously go up by 1. Today, the number of days between May 25th, 1975 and this moment is 16,173 days. Tomorrow, it will be 16,174. So if you are calculating the number of days in a fixed duration or in a dynamic duration, dynamic in the sense that one date may be a variable, like today. The date of today varies. It changes every 24 hours. And there's no reason both of these can't be variables. And you can get very creative in how you calculate the number of days between two dates using 0, 1, or 2 dynamic variables as the parameters to the days function. Now, when calculating date math, when performing date math, there's some additional functions that are very important for us to understand. Let's clean that up a little bit and save our changes. When we look at a specific date, in this case, June 30th, 2019, this single piece of data is actually the concatenated or combined result of 3 separate elements: a month, a day, and a year. 3 separate elements that are in fact 3 separate numeric values. There are times when we want to extract 1, 2, or all 3 of those values and operate on them independently. For example, if we wanted to add 1 year to June 30th, 2019, we'd have to do some fairly complicated and sophisticated calculations to allow for leap years, to allow for, when did the year begin? Are there 28 or 29 days in February? There's a much simpler way. There is a function in Ninox that allows us to extract the year out of a date. The function is YEAR, all lowercase, open parenthesis, a single date as the parameter in the closed parenthesis, and that will provide us with this year of date. The year of this date is 2019. The month of this date, and I'll grab another formula, if we use the function month, M-O-N-T-H, open parameter, a single date, and close parenthesis, the month of date is the 6th month, the month of June, and this obviously is being calculated on a calendar year. Your fiscal year may differ. And then the last formula, we can calculate the day of the date, and that is, in this case, the number 30. And we will call this function day of date. So now we have decomposed, we have deconstructed a single piece of data, June 30th, 2019, into its smallest components. A numeric field representing the year, a field for the month, a field for the date. If we want to calculate this date plus 1 year, it's very simple. We don't need to worry about leap years and non-leap years and all of that. All we need to do is reconstruct these 3 elements and add a little bit of math into the reconstruction. Let's grab a formula, and I am going to use the date function, D-A-T-E, open parenthesis. This function takes 3 parameters in order: a year, a month, and a day. We deconstructed a date by using the year, month, and day functions. We can reconstruct a date by taking each of those individual parameters or components, the year, the month, and the day, separating the numbers with a comma delimiter, and using these as three parameters in the date function, D-A-T-E, all lowercase. And that little bit of math, this is a number. If we want to advance this number 1 year, we just say +1. And that will provide us with the exact year ahead. If June 30th, 2019 is the current date, and we add 1 year to that, Ninox will know if it's a leap year or not a leap year and automatically give us this function. If we want to add 1 year, 4 months, and 3 days to this date, we just add a little more math. We've already added the 1 year. We add 3 months. We add 4 days. And we'll call this plus 1 year, 3 months, 4 days. 1 year, 3 months, and 4 days after June 30th, 2019 is October 4th, 2020. If our base date changes and is now, I don't know, April 23rd, 2018, 1 year, 3 months, and 4 days later is July 27th, 2019. We don't have to get into the number of months, the number of days in a month, 30 days, 28 days, 31 days, 29 days. We don't have to worry about any of that. We indicate the number of years that we want to add, the number of months that we want to add, and the number of days that we want to add. We add those to the individual components that make up the parameters of the date function in order: year, month, day, separated with a comma delimiter, and Ninox takes care of everything else to give us the exact point in time that is that number of years, months, and days in advance of the base date. This makes date math very, very easy. Now I want to show you one more function that's similar to the today function that we've already discussed, but sometimes you're going to want to use this as an alternative. The today function, and again, just to remind you, that is this function here. We'll call this field today. This function, it requires no parameters, and it simply reports back the current date of the according to the computer clock of the computer you're currently operating on. There is a similar function, and I'm going to add that formula, called now, also requiring no parameters. Now not only gives you the current date and time, and we'll call this field now, but it also gives you, the now function not only gives you the current date, it also gives you the current time. Today is the current month, day, and year. Now is the current month, day, year, hours, and minutes. So I just wanted to point out the difference between today and now. Let's continue. When we are working with dates, whether it's a month, a day, a year, or all three of those components put together, sometimes we need to change the way we look at that data. For example, here we see that for this date, April 23rd, 2018, that is the 4th month of the year. It is the 23rd day of the month. But what day of the week is April 23rd, 2018? Monday, Tuesday, Wednesday, Thursday, Friday, Saturday, or Sunday. We know it's the 23rd day of the month. What we need to understand, however, what certain calculations require is what day of the week is it. We are going to calculate the day of date according to the week, or what we call the index of this date. Now, to index this date, to understand what day of the week the 23rd day of the 4th month of the year 2018 is, we're going to use our weekday function. We're going to go into this formula field, and I'm going to use weekday, all lowercase, W-E-E-K-D-A-Y, open paren, a single date field is the parameter, and close paren. Now, it's important to understand when indexing dates according to the week, the index runs 0 through 6, 0 being Monday, 6 being Sunday. In this case, the date, April 23rd, 2018, is a Monday. And I can confirm that by popping up the picker and seeing, yes, indeed, that is a Monday. The index for a Wednesday, well, if 0 is Monday, 1 is Tuesday, 2 is Wednesday. So if I select the date June 6th, 2018, this weekday function or weekday index will tell us the specific day of the week based on a 0 index with Monday being 0. And in this case, this would make it Wednesday. 0 was Monday, 1 was Tuesday, 2 is Wednesday, and that is the day of the week that was June 6, 2018. There's other ways that we like to identify our days of the week. For example, by name. It's not necessarily consistent and intuitive to assume that everyone will understand that 0 is Monday and that the last day of the week is the number 6. That's not very clear. But we have another function that we could use called weekday name. Let's use this function, lowercase w-e-e-k-d-a-y, uppercase n, a-m-e in lowercase. And the parameter for this is the index number of the date, or what we called the weekday index. This number will return the name of the day that is that index numbered day of the week. The index numbered day of June 6th is the number 2. And if we apply the weekday name function using 2 as the parameter, that will return Wednesday. If we were to advance this date 2 days to the 8th, this becomes 4, and the name of the day of the week that is equivalent to the index number 4, of course, is Friday. 5 is Saturday, 6 is the last day of the week, Sunday. And it's important to keep this in mind. Some calendars have the week beginning on Sunday, ending on Saturday. Some calendars and some systems consider the first day of the week to be the index number 1, the last day of the week to be the index number 7. In Ninox, the first day of the week is day 0, and day 0 is Monday. The last day of the week is Sunday, and Sunday is index number 6. So using the weekday index and the weekday name functions, these can work in tandem. For example, I could have one formula, and I'm just going to copy the weekday date function, and I'm going to use that as the parameter in my weekday name. And it's going to look like this. What is the name of the weekday that is the index of this date? This date is a month, day, year. This function weekday will extract the number from 0 to 6 that represents the day of the week on which this date occurred. And this function will convert this number into a name. And of course, it will be the same name as the field next to it. If I were to advance or go back, say, to April 2nd, 2017, the calendar tells us that's a Tuesday. The index tells us that's a Tuesday. Monday is 0, 1 is Tuesday. This formula tells it's a Tuesday, and of course the other formula, as we would expect, tells us it's a Tuesday. And there are times when you may want to concatenate days and dates together. For example, if I want to know the day of the week of this date, I may present it in a concatenated manner. The name of the day of the week plus a space plus the date in question. That will give us the concatenated value of Tuesday, May 2nd, 2017. Compare that to this other date function that we have that just tells us May 2nd, 2017. This tells us the date. This tells us the day of the date. So keep in mind that weekday and that weekday name function. Very, very valuable, very, very helpful. And if you're wondering, yes, there is a similar function for the month index. Remember, this function, month, gave us the number of the month of this date. The date happened in May. According to the calendar, if January is the first month, that means May is the 5th month, and of course December is the 12th month. The month index and the day index are a little different. The first day of the week is 0. The first month of the year is the number 1. Weeks range from 0 to 6. Months range from 1 to 12. And if we add in this function, month name, and we add in a month or numeric index value, that will come back and tell us the name of a month based on the numeric value of that month. So we'll go ahead and place that right there. So we have this date, May 2nd, 2017. The year of that date is 2017. The month is 5. The day of the date is 2. We can perform date math by adding and subtracting months, days, and years using the date function as you see it right here. And in this case, we're adding 1 year, 3 months, and 4 days to the base date. We also, and I'll go ahead and expand that back out, we also can calculate the name of the month index. If this is the 5th month, if the index number of the month is 5, the name of the month that is index number 5 is May. The day of the week of this date, May 2nd, that's the weekday index. That's number 1. That's a Tuesday. Remember, weeks begin on Monday on a 0-based scale. And the name of the day that is indexed with the number 1, that name is Tuesday. Lots of different ways for us to look at dates as dates, or dates broken down into their component values of year, month, and day. So, some very valuable things that we can do, and we also can do some things with formatting. For example, what I want to do is present this date, May 2nd, 2017, according to its date and the name of the day of the week, but I want to truncate it down so the name is only 3 characters, the 3-character abbreviation of the name of the week. I can do that by using the format function. Let me show you what I mean. I'm going to take this formula here, which is the name of the day of the week plus a space plus the date that was used to calculate that name of day of week. And what I am going to do is I'm going to format this date to present with all four of these components: name of day, name of month, day of month, year. But I'm going to abbreviate the day of the week to 3 characters. Watch how we do it. We are going to go in and we are going to say the word format, lowercase format, the single parameter date, comma, open quotation mark, capital DDD, space, month, day, and year in 4 digits. So I want to take this date and mask it and present it visually according to the day of the week with indication by 3 letters, the first letter capitalized, month / day / year. And for months January through September, I want there to be a leading 0 for the month, and I want the day of the week to be presented numerically. And there we go. Well, that looks a little bit strange. I got what I wanted with the 05, that's May, 02, that's the second day of May. The year is right. I just messed up a little bit on this date, and the mess up was in using that capital D. If we make that a lowercase d, then I believe we will get exactly what we wanted. Keep in mind, when working in Ninox, and you've heard me say this many times, functions always begin with a lowercase letter. Parameters to functions are either other fields, other formulas, or keywords as defined by Ninox. In this case, we are using 4 keywords. DDD in all lowercase is the keyword abbreviation for the 3-day name of the day of the week, and Ninox will automatically calculate the first character. MM is the keyword indicator for a 2-digit month. DD is a 2-digit day, and 4Ys is a 4-digit year. And that gave us this. This date in Formula 4 is identical to the 2 dates above it. It just has a different visual presentation, a different mask, a different look, and that may be suitable in different situations. Sometimes we want to know exactly how many characters are going to be in a date. If we format it this way, we can always be certain, because the name of the day of the week will always be 3 characters. There will always be 1 space followed by a 2-character month, a slash, a 2-character day, another slash, a 4-character year. That's 4, 5, 6, 7, 8, 9, 10. The space is 11. Add 3, that's 14. We don't always know how many characters will be in this field. We don't always know how many characters will be in this field, because different days of the week and months of the year and days of the month have different length character strings. But this tells us exactly what we need to know, and we know it will always tell us that in exactly 14 characters. All the same answer, May 2nd, 2017. Different ways to formulate and format that answer to meet the specific needs that we have at any point in time in building our Ninox database. We can deconstruct dates into years, months, and days. We can reconstruct these 3 parameters using the date function to take the parameters, turning them back into a date, and we can do math within the date function to add time, to advance time perfectly and exactly without having to worry about leap years and the number of days in a month. Some have 31, some have 30, some have 29 once in a while, and one has 28. None of that matters if you use the date function and calculate your dates this way. And yes, you can also go backwards in time. If I subtract 1 year but add 3 months and 4 days, well, that would give us the answer that 1 year prior plus 3 months and 4 days to May 2nd, 2017, well, that was August 6th, 2016. You can go forward and back in time using this date math capability. I'm going to put this back the way it was and add a year so that I'm going forward in time. And there we go. Remember our indexing. The month index will be always a number ranging from 1 for January through 12 for December. The weekday index will always be a number ranging from 0 for Monday to 6 for Sunday. The function month name, which looks like this, takes a numeric parameter, which is the index of the month. In this case, that's 5. The name of the 5th month is May. The weekday index can also give us the name of that day of the week. The function is weekday name with the N in name capitalized, and the single parameter is the number of the day of the week, or what we call the weekday index, and that weekday index was calculated here. The weekday with the index number 1 in a Monday 0-based week is the day named Tuesday, and we can combine the weekday index function with the name of weekday function, and we'll get something that looks like this. The name of the index of the day of this date, and that is, of course, in this case, Tuesday. We then can concatenate, with or without formatting, the name of the day of the week with the date in question, in this case May 2nd, and get things that look like this, as we see here, or format to look like that if we want to exactly and explicitly define the number of characters. Maybe we're doing a fixed length download into a different system. So that's helpful if you know exactly how many characters you're working with left to right in your download. So that's a little bit about date math. That's a little bit about using date data to calculate and compute chronological time information. Let me show you a few other things that are built into these calendar tools. I'm going to go into the table number 1, called Calendar Events. And let me show you a couple of things that we've built here at Nioxus that you might find valuable and you might want to copy and use in your database solutions. For example, sometimes we may want to schedule a date and have that date appear on the calendar, but maybe it's not just one date. Maybe we're going on vacation for a week. Well, we know that if we put a date on the calendar, for example, I'm going to create a single date field, and I'm going to put today's date into that field, and that is Wednesday, the 4th of September, 2019. This is going to appear on the calendar, so when I go into calendar mode, there is the record that I just created. I can click on it, takes me right back to that record. But what if I want to create an activity that spans more than one day? Of course, I can create one date at a time, and if I have a 5-day vacation, I create 5 different date fields, each one indicating the date of each day of my vacation. Or we can use this little function that we built right here. We can specify a beginning date, let's say the 23rd of September, which happens to be a Monday, and an ending date, the 27th of September, which is the following Friday. That's a duration of 5 days. I click Create Calendar Events. It creates, and let's just get rid of those. Those are left over. And it creates the 5 days of my vacation. Here's the Monday, Tuesday, Wednesday, Thursday, Friday, 23rd through the 27th, and this is day 1 through day 5 of my vacation. We go look at the calendar, and sure enough, here's day 1, 2, 3, 4, and 5 of my vacation. And you see where it says day 3 of the, and it says in? Well, that's just a little feature we built that allows you to name the event. So this event is named Vacation, and the location might be Florida. Now, I'm going to go and create this event over again. I'm going to delete these records. And again, we're doing this one record at a time. We just as easily could go into the child table. And to do that, we need to display a hidden table. We go to our data model. The child table is event entries. I'll make this unhidden. And I'm going to go in and I'm going to get rid of all of these dates. Now let's look at that vacation again. Here is my vacation, September 23rd, Monday through September 27th, Friday. This event name is Vacation, the location is Florida, and I also have a repeating reminder that monthly, on the 21st of each month, we have a monthly meeting, and these icons tell me that pizza, tacos, burritos, and cheeseburgers are being served at the meeting. That's not a meeting I want to miss. I'm going to go ahead and create calendar events by clicking this button, and here are the two the two meetings on the 21st. Here are the 5 days of my vacation. Day 1 of the vacation in Florida, day 2, 3, 4, and 5, and when we look at the calendar, it looks like that. So it's a very nice way of creating a sequence of days sequentially that make up a multi-day event. And we've built this function. Again, you can download this from the member portal at www.nioxus.com. It is free. It is open code. There are no passwords. And you can use this function to create a series of dates. You just click this button, and if you want to learn how we did it, go into administrative mode, go into the parameters of the button, and bring up the formula. It looks complicated. I promise you it's not. We have intentionally avoided using any shortcuts in the construction of this formula. So we have explicitly called out the name of every day of the week. We've made it very simple for you to understand how we built these formula. The other functions that are available in this worksheet, you can schedule reminders. Let's go ahead and do that. I'm going to delete this record, and I'm going to create a date, the 26th. That's a Thursday. The event name is Important Meeting. The location is the boardroom. I want to be reminded of this specifically the week before, on September 19th. And it's going to be Important Meeting Soon. And this is a regular priority. And then I want to be reminded the day before. And this is going to be all caps, Important Meeting Tomorrow. And this is going to be a high priority warning. And then I want to schedule a follow-up date for the day after to remind me to send out minutes from yesterday's important meeting. So I have one date that I want to schedule, September 26th, when I have an important meeting in the boardroom. When I click Create Calendar Events, it creates 4 dates: the date, the first reminder, the second reminder, and the day after follow-up. And on the calendar, it looks like this, with the color coding corresponding to the date itself in blue, the follow-up in bright yellow, the first reminder in a more relaxed or slightly darker yellow, and the important reminder, that second reminder, in the red. If I had wanted to make this, and I'll just delete that. Well, you know what? I'll just do it again. But this time I'm going to make this an urgent priority. I'm going to schedule it again. And now when we look at the calendar, we can see that really bright, bold red, which is the most urgent reminder. So you can schedule with this utility a series of dates, beginning and ending at a certain point in time. You can schedule reminders, up to 2 reminders and a follow-up. And then finally, you can schedule recurring dates. Let's look at how that works. I'm going to go in and create an event. And the date of the first event is the 2nd. The reminder frequency is going to be weekly. And I want to schedule the next 12 weeks. And the reminder text is weekly team meeting. Now, what this utility is telling me is that 12 events will be scheduled 7 days apart, starting on Monday, September 2nd. We create the calendar events, and sure enough, the next 12 Mondays are scheduled for our weekly team meetings. Team meeting number 1 on September 2nd, all the way through team meeting number 12 on Monday, November 18th. If you would like to use any of these utilities, again, go to the Nioxus member portal, download the Calendar Tools template, and this will have all of the date math with all of the examples of indexing and naming, now and today and durations and everything we talked about. And we also provide you with this calendar events function template that allows you to schedule series of dates, reminders and follow-ups, and repeating dates, which repeat on a schedule of daily, weekly, monthly, quarterly, every 6 months, or annually. And finally, the last table in that utility, in that template, is the help table. This tells you what every field and what every table and what every piece of code is used for in this function. So for example, if you want to know how we created the code, how we programmed the function to post multi-day events, well, that's the code snippet, lines 66 through 77. We see it right there. And if we go to the code, remember the code's in this button, we go to administrative mode, bring up the parameters, look at the code, and go look at code lines 66 through 77, there is the section that allows us to calculate duration of dates or recurring dates or sequential entries. So if you want to study a particular function, for example, how did we build the code that allowed us to schedule a series of dates one after another to schedule out an event spanning multiple days? Go to the help go to the help table and see how we were able to post events, which is right here. And this will tell us what button to go to. Here's an explanation of all of the details of that button. And then here's all of the code to post multi-day events. Again, that's line 66 through 77. How to do non-sequential series, how to post reminders and follow-ups. All of it is detailed here. So as you are studying and learning how to do date math, I strongly encourage you to go to the Nioxus portal, get your free password if you don't have one, go into the member portal, and download Calendar Tools. Play around with it on your own. Follow along as we do these exercises in this training class. And in a very short period of time, you will be an expert in date math in Ninox. That's it for this class. I hope you had fun. I hope you enjoyed yourself, and I hope you learned a lot. Download the template, play around with it. It's not complicated, it's not difficult, and very quickly you'll be able to use date and chronological and calendar content in your Ninox solutions. Please come back and join us for our next training class. And in the meantime, go out, have fun with Ninox, and I'll look forward to seeing you again very soon in the classroom. Bye-bye, everybody.